I'm excited to be here and speaking to the Alliance again. This will be my third time presenting here to this group. And I really appreciated hearing Tyler's story. And I admire that he saw and recognized that something wasn't working in his practice and asked that question, what's going on? And he figured this out. My experience, for those that have heard it before, quite different. It wasn't until I experienced chronic pain and wasn't getting better with all the education and knowledge and going to healthcare that I finally asked the question and figured this stuff out. So that's real exciting to hear his presentation. So I am in Tri-Cities, Washington, and physical therapist by training. Based on my experience with chronic pain, I've started to branch out into coaching and education. And I'm going to be speaking at the Tri-Cities Pain Conference next week. And Raleigh approached me and said, hey, do you want to be able to run through your presentation in advance and get some practice? This is a great opportunity for me to share this with you in advance of when I speak next week. The three objectives for my talk today is to first talk about what the purpose of pain is. And then we'll get in a little bit about that purpose, which is protection, and how it can go rogue, resulting in persistent pain. And then evidence for how we can reverse these changes in the nervous system that have resulted in persistent pain. So those are some of the things I'll be talking about. But before I get into that, I really want to hit on this big, long, almost scary sounding word, neuroplasticity. And to really understand what I'll be talking about tonight, we need to have this foundation of neuroplasticity. Neuroplasticity is kind of broken into two words formed together. Neuro means nervous system, kind of the neurology and things. And the term plasticity means to change, adapt, learn. And so this term neuroplasticity describes the process of our nervous system to learn and to adapt or change over time. Anytime we learn something, such as we learn how to play an instrument or we memorize something, we gain knowledge or develop a skill, when we're children walking, that results in changes in our nervous system. And these are neuroplastic changes that allow us to learn new information and retain it. It's also responsible for when we develop bad habits. Those habits tend to stick because of neuroplastic changes. And these changes are also reversible. Once they take place, they're not permanent. They can be changed. It's just like bad habits. They can be changed and overcome. Can be difficult sometimes, but once they're formed, they're not permanent. They are reversible. So neuroplasticity, when you hear that, just think about, that's learning and how our nervous system can change and adapt over time. Oh, I love this picture because usually when I'm speaking in front of an audience, I hear audible gasps from the crowd. I'm sure when you guys saw this picture, you didn't have to take a moment to analyze if there was something dangerous or harmful. You almost had a physical reaction when you saw that. And that's because our bodies have processes built in to detect threat, harm, and dangerous situations. And this is very important because we need to be able to protect ourselves. So pain is one mechanism that the body uses to protect ourselves. And I like to describe pain as kind of a danger signal. When we think about this particular picture, if that foot came down on that nail, you would experience pain. It warns the body or you that something's wrong. And because we tend to associate pain with some kind of injury, over time, we've started to believe that pain resulted from maybe a pain receptor in the body, and it traveled up a pain pathway to a pain area in our brain, and it rings a little bell and says pain, pain, pain. But we are starting to learn that that model, while it makes intuitive sense, isn't quite accurate, and pain's a lot more complicated than that. So for some examples, here we have some different images. The football players, they're out on the field, they're hitting each other, they're having a good time and things. And when they're getting hit, they're getting bruises, scrapes, scratches. They might even come off the field with some minor sprains or strains occasionally. But for the most part, you ask them, hey, are you in a lot of pain? No, they don't have pain. They're having a great time, even though they are experiencing some tissue damage. Migraine headaches, these can be quite severe, disabling for people, but there's no structural or physical problem that can be identified. There's no damage, but there's quite a bit of pain. And then individuals who have experienced amputations, these individuals no longer even have that structural tissue, and the limb is missing, and yet they can experience quite severe experiences of pain in the limb that's no longer present. So we know that pain's a lot more complicated than just a pain receptor in the periphery of the body that sends a message up through a pain pathway. So to get into our next slide, I just wanted to go over a widely accepted definition for pain, and this is from the International Association of the Study of Pain. And it's described as an unpleasant sensory and emotional experience associated with or resembling that associated with actual potential tissue damage. There's some important things to point out about this definition. It is an experience, it's conscious, it's unpleasant, and tissue damage is not required to experience pain. We also now know that biological, psychological, and social factors influence our experience of pain, and that pain can start to adversely affect our function and not just provide that protection, but it can start to adversely affect the function as well. So for pain to protect us, ultimately, these unconscious processes in the body, in our nervous systems, are involved in developing pain. Ultimately, it decides whether or not to produce pain as it answers this one question. And the question is there something threatening or dangerous to your body, to your survival? And if there's nothing threatening or dangerous, there's no need to protect. But if it finds that there is something threatening and producing pain would promote a protective action to continue your survival, our nervous system is going to produce that pain to get you to act. Just like we saw that picture of the foot coming down on the nail. If your foot came down on that nail, you'd experience pain because you need to get medical care for that. You might walk a little funny to protect that while it's healing. You don't want to just be walking around with this injured foot and continue to produce further harm or damage. So let's get into a little more of the nuts and bolts about this particular model. Was introduced by Lewis Gifford, called the mature organism model. And he identifies a lot of different things that our nervous system, our body uses to answer that question, whether there's danger or threat to you. So the first thing we'll identify is our bodies utilize information from our environment, as well as from our tissues. So this is what we observe around us, as well as that sensory information coming through our sensations within our bodies. And then it's going to scrutinize and decide if there's threats utilizing a lot of different information. Things like our past experiences, our knowledge, beliefs, culture, things that have been successful, stress and trauma, and our emotions also affect this. And ultimately, we get the output, whether it's pain or changes in our physiology or altered behavior in order to protect ourselves. So we're going to give an example of how this process can work in different individuals. So some of you, when you saw these hot peppers, you might have been like, whoa, hot, that's danger. You don't want anything to do with peppers. And other people may have been like, ooh, I like hot peppers. That looks good. Hot peppers have a chemical in them called capsaicin. And this chemical activates nociceptors that respond to noxious heat stimulation. That's why often people describe peppers as hot, because they're activating receptors that detect heat. And we also know that nociception information within the body does not equal pain. It's just one piece of sensory information that the body uses to determine threat or danger. So some people, when they eat hot peppers and spicy things, they have a good experience. Perhaps they grew up eating hot peppers or hot spicy food in pleasant social situations with family. It reminds them of grandma's hot tamales or good experiences. Or somebody else eating the same spicy food may have a completely different reaction and respond with complaints of extreme pain. Perhaps their experience much different. Perhaps somebody played a trick on them when they were young and fed them something spicy, or perhaps after using some language that wasn't appropriate, they were punished with hot pepper sauce, and they completely learned a different response to that same experience, eating something spicy. And so pain is a learned concept, and it's influenced by our life experiences, and it results, as we learn about pain, in these neuroplastic changes within our nervous system for how we detect and respond to threat. So I'm going to demonstrate another model for you of how we can look at the nervous system and how it detects threat and danger and produces pain. And this takes a look at if we were to measure electrical activity in our nervous system. Our nervous system, the nerves work on electrical impulses. And towards the bottom of the graph, there's a squiggly line all the way across the bottom to indicate this baseline electrical activity that's always in the nervous system. But when it detects danger or threat, that electrical activity in the nervous system ramps up to create that experience of pain. And this pain will persist until that danger or threat has determined by the body to pass, and there's resolution in the nervous system where that electrical activity calms down, the pain goes away, and we're now at just a baseline resting level. So what happens when we don't see resolution in the nervous system and it's continuing to generate pain and continues to detect ongoing danger and threat? And this is really what's behind persistent and chronic pain. For certain reasons, which we'll discuss later, our nervous system that is designed to detect threat or danger gets stuck continuing to detect ongoing persistent threat or danger. And these neuroplastic changes result in an ongoing experience of persistent pain. So what neuroscientists have found is that neuroplastic changes take place in areas of the brain involved in detecting threat and danger, and they start to interpret safe sensory information, meaning sensory information that's not threatening or harmful to the body, starts to misinterpret that as dangerous or threatening. And this can change, distort, and amplify pain, and it can increase its degree, its duration, as well as how it starts to spread and can be experienced in wider areas throughout the body. It results in kind of a disconnect between the intensity of peripheral stimulation and the severity of pain reported. Things that typically may feel pleasant or non-threatening or dangerous start to produce pain. And this results from actual functional changes within the nervous system. And it's quite remarkable because they can actually detect these changes when they look at brain function on MRIs. These are examples of findings from what's called a functional MRI study, where they'll take individuals and they'll scan their brain to look at function when they receive some kind of stimulation. And so we see that the scan on the left, there's no activity seen there. This is an individual that doesn't have these neuroplastic changes that I've described in their nervous system. And the stimulation that they provide to these people to what they call provoke back pain is actually just a little air bladder, kind of like a blood pressure cuff that's placed underneath these individuals' low back when they're laying down, and they apply a little bit of pressure by pumping up that air bladder. It's not dangerous. It's not a painful stimulation for most people, but individuals that have these changes in their nervous system detecting threat, that gentle pressure on the low back is interpreted as dangerous, and the areas of their brain involved in detecting threat and pain light up, and they report it as quite painful, even though it's not a harmful stimulation to the body. So it's quite remarkable to see that there's objective actual changes in how the nervous system functions and how these individuals are perceiving threat and danger from within their bodies and their environments. What I like to do when I teach this to my patients is to use analogies. We can all connect with analogies, and they help make things more realistic and make sense. So the analogy that I go to is an alarm system on a home. If we have an alarm system set up, say monitoring a window, we want it to be armed and active to warn us if somebody's breaking into that window. And if somebody breaks in, the alarm should go off, call security, be maybe loud enough to scare the intruder away, let us know, hey, something's wrong, so we can take care of this. Now, if that alarm system is not set up properly, and now it's detecting just subtle things that are not dangerous or harmful, such as leaves blowing against the glass, and every time there's a wind that rustles the glass, the alarm goes off. It's no longer an effective alarm to warn us when somebody's trying to break in. And it's not that there's something wrong with the window, there's something wrong with the alarm. It's detecting things that are not dangerous. And that is similar to these neuroplastic changes that have taken place in individuals with chronic pain. And chronic pain complaints resulting from these neuroplastic changes, this is real pain. It is a real experience, and it could take place in any part of the body, often multiple parts of the body. And they're very frustrating for patients and providers because they mimic real physical and structural problems. And the rates at which neuroplastic pain occur are quite high. About 1 in 4 individuals develops a neuroplastic pain. We often in healthcare actually see a lot more of these individuals because they're not getting better. They keep coming back to us. They have these persistent complaints. It's believed that as high as 40% of all complaints in primary care are the result of neuroplastic changes, and that chronic back pain rates are as high as 70 to 80% or even higher from some sources result from neuroplastic changes. So the big question is, how or why are these changes taking place in these individuals? And they've been able to identify risk factors for why these develop. And those risk factors tend to be things that are psychosocial in nature, and they result in persistent stress, fear, or threat activation in the nervous system. So those can be just stressful personality types, people that have poor self-care skills, they're always pushing themselves, maybe type A personalities that go. People who've experienced adverse childhood experiences, I've had abuse or trauma, their nervous system, just because of that constant threat from those experiences, is always on a high alert, kind of in danger mode. People with unrecognized negative emotions or emotional health related things, these could put the nervous system on high alert. A lot of that language that Tyler talked about from the medical profession that increases fear, people talk about MRIs or X-rays or other things that were found in imaging studies. And these may be things that happened years ago and healed up, or things that we now know actually are just the normal process of aging and don't have any impact on pain for most individuals. Because of these fears and beliefs, they have ongoing pain taking place. Stressful environments, financial concerns, and then another one, people with catastrophizing personalities. All of those put the nervous system on high alert. And when it's in a stress mode for a long enough period, we know that with neuroplasticity, neurons, which are the cells that make up the nervous system, when they fire together, they start to wire together. And so with these ongoing stresses in the nervous system, over time, when these are sustained, it results in these neuroplastic changes associated with threat and danger, and pretty soon pain becomes chronic and persistent. So that's the reason we're seeing these neuroplastic changes. And often when I'm working with a patient and they're not getting better, I'll start to ask them a little bit about their background, their history, learn some of these things. And this particular slide, I had a similar card that I was using with pain education. And I showed it to one of my patients that wasn't getting better. And she looked at it, she's like, that's my life. When people aren't getting better, you start asking these questions, and pretty soon you can put this picture together. What's causing their threat and danger, resulting in that pain to persist? So we're going to get into the last topic here, and that is, how do we unlearn pain, if you will? How do we reverse these neuroplastic changes that have taken place that is resulting in this persistent chronic pain? And for those of you that have been involved with the Oregon Pain Science Alliance, you've probably seen the pain fire triangle, I guess we'll call it, that Dr. Kevin Coccaro came up with. And I love this model because I think it takes a good job of taking those psychosocial characteristics that are involved in pain and kind of grouping them. So let me explain this triangle for a second. So we know that a fire requires three things: oxygen, heat, and fuel. And we can compare that to pain. Pain can result from sensations, and that might be described as a fuel. So these are things like structural or physical sensations within the body. But it also is influenced by cognition, our fears, our beliefs, that threat, as well as emotions, our mental health, and how we're doing. So I think you can take all of those factors that I described in the prior slide, and we can kind of break them down and group them into cognition or emotion in general. They kind of fit in there. So to retrain the brain to overcome pain, I think you need to first recognize what is the source that really is driving this individual's pain experience. And when you identify that, then you look at what interventions can help to resolve that problem. And the studies that we're going to look at one that first addresses emotional items and then one that addresses cognitive items. This first one, a VA pain study, took place in the LA VA system, and it was mostly older adult male veterans. And the beliefs that drove this study was that pain results from these brain-based neuroplastic changes, and that they're resulting from unresolved trauma, psychological conflict, stress, or unhealthy ways of dealing with emotion. And if we can teach people and address those factors, we believe their pain's going to come down. So emotional awareness and expression therapy teaches disclosure, expression, and processing of avoided emotions and engagement in healthy behavior. And for the group that received that therapy, 40% of the individuals had a reduction in pain, and it was sustained after 3 months. And then the control group that just used the typical go-to approach of cognitive behavior, they didn't see the same results. And it was really neat to hear about this study. The physician that introduced it, he said, this group of individuals, older adult males with veterans, particularly with pain, this is where pain study goes to die. They don't see this good results working with this group in pain studies and treating pain. So quite remarkable results for this population. The next study looks at more the cognitive, the beliefs that contribute to somebody's pain experience. This is one using pain reprocessing therapy with their landmark study from the Boulder Back Pain Study. And the concept behind this is people with chronic pain often believe that their pain is resulting from a physical, structural, something wrong in their bodies, resulting in an ongoing fearful appraisal of sensory information as harmful as tissue damage, as something wrong in their body. So they avoid behavior, and it results in this ongoing negative feedback loop. So pain reprocessing therapy emphasizes patient education about the nervous system. The body heals. Often beliefs about structural damage are kind of false. I guess you don't tell them that right out because you need buy-in, but these are false beliefs about what's causing their pain, and teaches how to reassess or reappraise that sensory information as safe as they gradually safely expose them to those activities that have caused them pain. And through that process, they're able to reassess that information and their pain subsides. And they had quite good results here. At least 90% of the treatment individuals had some reduction in pain, and about 60% had note little pain by the end of the study, and that was maintained compared to a placebo group and the usual care groups. But the other thing that I'm really excited about this study is not only did these individuals report less pain, when they went back and they looked at their nervous systems, they saw objective findings on imaging that the function of their nervous systems changed, and those areas involved in detection of threat and fear and danger, that activity calmed down as a result. So it wasn't just subjective reports, yes, my pain's better, but they had objectively, this stuff changes how the nervous system functions. So that's quite remarkable. And then the last item that I'm going to go over with you guys tonight is just something to think about when you're trying to determine, do I or do my patients or whoever it is, do they have a physical structural problem, or do we have neuroplastic type pain? And the first thing, especially for healthcare providers, is we have to rule out those physical structural sources of pain. We don't want to miss an injury, cancer, something else that needs medical treatment or care. And for most people with chronic persistent pain, these items have been ruled out. They've seen multiple doctors, they've had multiple imaging studies, they've seen specialists, and they've had treatments that are effective for treating physical and structural items. And so often, if they've had all this stuff done and they're still having pain, it's highly likely that they have a neuroplastic pain. And then you want to look for those emotional and cognitive psychosocial risk factors that we talked about and how you can reverse those. And then the last thing is to assess for neuroplastic pain presentation patterns. And those are items that really take a look at how this type of pain presents differently than structural and physical pain types. And so I'm going to review some of those next. Some of the things you'll see with neuroplastic pain is that stress makes their pain worse, and reducing stress makes it better. Another thing you'll see with neuroplastic pain that doesn't occur with structural pain is the pain will move around their body. You know, one day they have it in their knee, the next day it's in their shoulder, tomorrow it's going to be in their neck. And so it bounces around and it's not consistent like we'd expect with structural pain. Pain that didn't respond to medical treatments, that can be an indicator it's neuroplastic. Pain that came on without trauma or injury to the body, or it's been 3 to 6 months since they had an injury and they're still in pain, or they'll describe what they recall as what brought on their pain, and we find it's not really something that we'd expect would cause physical damage to the body. And the example I give is somebody that describes their pain started after they injured their back because they took an 8-hour flight across the country or something. You know, sitting might be uncomfortable, but it's unlikely to cause physical damage to the body, at least as far as sustaining an injury. Pain that starts to include multiple locations throughout the body. It's not very common to have independent injuries at the same time. This can be an indicator of pain. And then lastly, one of the presentations patterns you'll see is that doctors don't know what the cause of the pain is. That can be a strong indicator that it's neuroplastic. And so I think that's where I'm going to wrap up my presentation tonight.